morning. Okay, today we are going to solve the exercise for questions 22 for the subject numerical methods. Okay, the question 22 here, there is a mistake here from the original questions. Okay, the b here should be, this should be negative 2b. So the natural cubic spline is defined by the S0 and S1 x here. If the S interpolate the data 1, 1, 2, 1, and 3, 0, find B and D, where the S0 defined from 1 to 2, S1 from 2 to 3. Okay, we use condition number 2 of the spline function. Means spline. If we plug in x equal to 1, means S0 1. Okay, S0 1 should be equal to F1. Okay, so S0 1. Okay, so when you plug in 1, 1 is actually equal to F1, which is 1. Okay, when it's satisfied, this is actually condition number 2. Okay, later on we try to, so when you plug in S0 2, it should be equal to 1. S0 2 should be equal to F2. Okay, and we find the S0 2, mean plug in x equal to 2. So you have 1 plus b minus d, because x is 2. 2 minus 1, this is 1. So minus d. And the answer should be F2 is actually 1. So mean you have b equal to d. This is the first equation. Okay, and similarly, we can plug in 2 into the S1. The answer should be equal to F2, which is 1. Okay, so S1 when x equal to 2, okay, when x equal to 2, you have actually A, because 2 minus 2, 0, 2 minus 2, 0, 2 minus 2, 0, you have only A equal to 1, because F2 is 1. Because F2 is 1. So we have A equal to 1. Okay, later on, if we plug in S1, when x equal to 3, so have A minus 2b minus 2b. So 3 minus 2 is 1. So negative 3 over 4, because the third term 3 minus 2 is 1. Okay, plus d. 3 minus 2 is 1. So sk when S1 3 should be equal to F3. Mean F3 is equal to 0. Mean when you plug in x equal to 3, the answer should be 0. Plug in x equal to 2, answer is 1. Plug in x equal to 1, the answer should be equal to 1. Okay. And then we plug in A value is actually 1. So we have 1 minus, and then B equal to D. So mean put it here. Mean D here we let it equal to B. So total is 1 minus 3B minus 3 over 4 equal to 0. So you have 3B equal to minus B plus B. This is minus 2B. Minus 2B plus B, because D is equal to B. So minus 2B plus B, this is minus B. Minus 2B plus B minus B. So this one erase. So B bring to the other side. So B will be equal to 1 over 4. So this is number 3. Okay, since B equal to D, that's why D also equal to 1/4. So you obtain B is 1/4, D is 1/4, and A is 1. Okay, and since this is natural cubic spline, okay, we can find the from S node. Okay, where's the S node? Okay, our S node is actually 1 plus b x minus 1 minus d x minus 1 cube. Okay, mean if you differentiate, okay, s naught prime at 1 plus b minus 3d okay, x minus 1 cube. Okay, and then s naught double prime, okay, s naught double prime is actually, okay, you have negative 6d x minus 1 cube. Okay, for the natural cubic spline, so the second derivative s naught, okay, at the, okay, mean here the starting point 1 should be equal to 0. Okay, let me check. S naught double prime, when you plug in 1, okay, it is true, we get 0. Mean for natural cubic spline, S naught double prime, when you plug in 1, should be equal to 0. And we plug in 1 here, okay, it is true, it is 0. So mean this is natural cubic spline. Okay, and then for natural cubic spline also, okay, the, okay, second derivative for sk1 for the, okay, ending point here, which is 3, should be also equal to 0. Okay, then we try to check the S1 is actually a minus 2b x minus 2 minus 3 over 4 x minus 2 squared plus d x minus 2 cubic spline. So up to the cubic term. Okay, and then we find the first derivative. So differentiate constant 0 differentiate, okay, negative 2b times x minus 2, you have negative 2b. So differentiate, this is a, okay, power 2. So you have 2 times 3 over 4. Okay, power, okay, will reduce 1 for differentiation. The last term, you have 3 times d x minus 2 squared. Okay, and then for second derivative, differentiate first derivative one more time, differentiate constant 0. Okay, and then this will simplify. This is negative 3 over 2. Okay, power 1, so it just left negative 3 over 2. Okay, the last term will become 6d x minus 2 power 1. So when you plug in 3 into the second derivative of the s1 function, okay, 3 minus 2, plug in here, negative 3 over 2 plus 60. 3 minus 2 is 1. Okay, and we let it equal to 0. We want to double check, okay, whether it satisfied the natural cubic spline. Okay, and then so the 6d will be equal to 3 over 2. So d is actually 1/4 as what we found in the beginning, number 4 here. So mean, okay, here the mistake, this is negative 2b, negative 2b. To find, okay, the ABC, we just use, okay, the, mean when you plug in 1 into S node, the answer should be equal to 1. You plug in 2, because when x is 2, the, okay, the y or your cubic spline function should be equal to 1. When you plug in 2 into the S1 function, also, okay, S1, mean, okay, you plug in S node 1, the answer should be equal to F1, which is 1. S node 2 should be equal to F2, the answer is 1. Plug in S1, 2 should be equal to F2, the answer is 1. If plug in S1, 3 should be equal to F3, the answer is 0. Actually, we use these 4 conditions, we can find ABD. ABD, okay, but and natural cubic spline also satisfy, okay, S naught double prime for the starting point will be equal to 0, s1 double prime for the ending point 3 should be equal to 0. Okay, and we do it. Okay, we also get the constant, okay, consistent d equal to 1 volts. Okay, with this, okay, thank you for your attention.